In this question, we're going to have a look at differentiation and finding the equation of a tangent using differentiation. So to start with, we're going to use the fact that if y is equal to e to the power of kx, then when you differentiate the right-hand side of the equation, it gives you ke to the kx. So in this specific case, we know that if y is equal to e to the 4x, dy by dx is equal to 4e to the 4x, according to this rule. Before we move on to the rest of the question, let's talk about what it's asking us to find. So the equation of a tangent to a curve. So if we draw a brief curve of, sorry, that's horrible, an exponential curve like e to the 4x, it's asking for at the point a e to the 4a. We don't know what that point is, but let's just say it's this point. A tangent is a straight line that meets the curve at one point, and what we know about the tangent is that the gradient of the tangent is equal to the gradient of the curve at that one point. That's why dy dx is helpful, because dy dx, I'm just going to select off of this because I'm going to cause some ruckus. But dy dx, it gives you the gradient of this tangent, this straight line. So a straight line is in the form y equals mx plus c. You want to find the values of m and the value of c, and that will give you the equation of the tangent. Let's focus on finding the value of m. So the gradient of the tangent we mentioned is equal to dy dx at that specific coordinate. So because we already found dy dx, we substitute in the x coordinate at that coordinate, which is a, and we say it's equal to 4e to the power of 4a. That's as far as we can go for now, so we're going to leave it there. So far we have y is equal to 4e to the 4a as the gradient of the tangent, x plus c. We now need to find the value of c. Since we know the x and y coordinate that the curve and the tangent crosses through, specifically the tangent because we're trying to find the equation of the tangent, we're going to replace y with e to the 4a. It's equal to 4e to the 4a multiplied by x, so multiplied by a, which is 4a e to the 4a plus c. Take away 4a e to the 4a from both sides and you get that c is equal to e to the 4a, whatever's already on the left hand side, take away 4a e to the 4a. Now we can write a whole equation for the tangent, which I'm going to do. I'm just going to rub out the plus c that I wrote beforehand, just to make things simpler. And then we can replace that plus c with what we just found. So e to the 4a minus 4a e to the 4a. That's as far as we can go for now, so I'm just going to leave it there. Quite a messy answer, but can't really simplify anything yet. Can't add any terms together. It then asks in part B for you to find the value of a for which the tangent passes through the origin. How do we find that? Well, I'm just going to change pen color quickly. It passes through the origin at the coordinate 0, 0. So we start by making x and y both equal 0. So the left hand side of the equation equals 0, and that's equal to 4e to the 4a times 0, so that's just 0, plus e to the 4a, and then minus 4a e to the 4a. So essentially what you want to do is solve this equation. Straight off the bat, we can factor out e to the 4a from these two terms because it's a common term in both of these two terms. Factoring that out, to get from e to the 4a to this term here, you multiply by 1. To get from e to the 4a to minus 4a e to the 4a, you multiply by minus 4a. You say all of that's equal to 0. Sorry. Now, what we know about the exponential curve is that it will never touch the x-axis. So that means that this here will never equal 0. The only case where the left-hand side equals 0 is when this bracket here equals 0. So we set 1 minus 4a is equal to 0. Add 4a to both sides, so 4a equals 1, and then divide both sides by 4, so that a equals a quarter. And that's everything for this whole question. Quite a tricky question, which is why I wanted to go through it, but yeah, if you have any questions with it, just let me know in the comments. Otherwise, please like the video if it helped. Be sure to subscribe. I'll post a new video every single day. And yeah, I've linked my email in the description if you have any tutoring inquiries. Be sure to reach out.